Hey everyone, welcome back to my Calculus 1 series. In today's lesson, we're going to be going over optimization problems. So firstly, optimization problems are basically problems that ask us to maximize or minimize something. I'm going to give an example later and we're going to see exactly what I mean by something, but it's generally like a formula. A lot of the times, some of the questions they give us have to deal with like area or volume. So you're looking at like, oh, what are the maximum dimensions to maximize volume, or like to maximize area, whatever, if you're in 3D or 2D. But basically, to solve them, we must basically meet a few criteria, right? One, we need to understand what needs to be optimized. After we figured out what needs to be optimized, right, we need to figure out what formula we can use to maximize that something. And again, I'm referring to that something, but we'll see a lot of the times again, it's area or volume. After we figure out the formula, right, let's figure out if it needs to be maximized or minimized, because there are times where you would like have a local min and a local max within that same interval, and it could be a little confusing. So it's important to know if we're being asked to maximize something or minimize something. After we have figured out these prerequisites for the problem, we want to find other relationships that can basically help us eliminate variables in this formula right here. And lastly, we are going to find the derivative and find the local mins or maxes, whatever is needed. So there we go. These are kind of our steps. A lot of the times it does help drawing a diagram to figure out what the problem is asking. So we're going to go ahead and jump into an example problem. I'm going to write it down and then we're going to go over the solution. So here is the problem statement. It says a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fencing along the river. What are the dimensions of the field that has the largest area? So like I mentioned, it's probably useful to draw a little diagram to see what's going on. So let's pretend that we have a river somewhere here. There's our river, and he would like to fence off a rectangular area right here, right? So we know that in a rectangle, this side and this side are the same, and this side and this side are the same. So opposite sides are the same. However, the question stated that he does not need any fencing along the river. So there's no fencing needed on this side. So I'm going to go ahead and label this side Y and this side X and also this side X. So there's our little diagram, right? And let's now break the question down and figure out exactly how we're going to formulate this and how we're going to, what formula we're going to use basically to find the derivative of. So the question asks us to find the dimensions of the largest area, right? So this gives it away that we're going to be maximizing the area. And the area formula of a rectangle is given by x. In this case, it'll be xy. A lot of the times you'll see it just as like length times width. But in this case, because I labeled it x and y, it's appropriate to write a is equal to xy. So this is our area formula. However, we can see that we have two variables here, and we can't yet find the derivative of that. So what we need to do is find other relationships between these variables that will help us eliminate one of these variables. And it's pretty obvious here, but it says that the farmer has 2,400 feet of fencing. So what we know is that if we were to sum up the perimeter of this thing, excluding this side right here, we should get 2,400. So we can write that relationship as such. We have two x sides and a singular y side, and their sum should equal to 2,400 feet. So there's our equation. Now that we have two equations and two unknowns, we can use one of the equations to eliminate the variables from the other formula. So we know that this is the formula we're going to be needing to maximize. So the chances are is that we're going to need to use this formula and eliminate a variable from this formula. So I'm going to go ahead and do that right now. I'm going to rearrange this formula and say that y is equal to 2,400 minus 2x. And now we can plug this y, the content of the y, into this formula and basically eliminate that y variable. So I'm going to go ahead and do that right now. Now that we have only the x variable, I'm going to simplify this formula. So there you go. Now we have come up with an area formula, and we need to maximize this, right? In order to maximize something, we know that we must find where the derivative equals 0, because that would be a local min or a local max. So let's go ahead and find the derivative of this function. There's our derivative, and now we know that we would need to set this derivative equal to 0 to find out where our local mins and maxes lie. Now I'm going to solve for x. So there we go. We have found our x value, and all that's left to do is to find the corresponding y value. The y value is expressed through this formula, so we can go ahead and plug in our x value and find our y value. So there we go. We have found both our x value and our y value. And in this case, we are done, because the question asks us for the dimensions of the field that has the largest area. If you want to be more specific, we can say that this will be 1200 feet and then this will be 600 feet. But that's just for the units. But again, it's asking us for what are the dimensions of the field that has the largest area. Sometimes they'll ask for what is the largest area, and you're going to have to go ahead and do an extra calculation. So just be careful of what they're asking for. But in this case, we are finished. So that's a pretty short lesson on optimization problems. Essentially, all of them are very similar. We want to find the formula that we need to maximize or minimize. Then we want to find some sort of other relationship, eliminate a variable, find the derivative, and then find where the local min and max are. I hope you guys enjoyed the video. If it's helped you out at all, please like and comment as to what I helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I will catch you guys in another video.